So, hello friends. Today we will study a very important topic of maths that is called circles. So, what is circle? A circle is a group of points which have a constant distance from a given point, say O in my figure. This constant distance is R and is called the radius of the circle, and O is called the center of the circle. But before moving on, let us see what is a locus. Well, as per definition, locus is a group of points which follow a specific rule. That is, a circle follows a specific rule that every point on the circle must have a constant distance from a fixed point O. So that is what is a locus. Any point which follows a specific rule is a locus. A straight line is a locus. A parabola is a locus because they follow specific rules in which they are made. And let us look at the equations of circle, which is the only thing we will be doing today. First of all, the analytical definition of a circle. By definition, we know that the distance of any point is constant from the center, and using this, we have certain circles, predefined circles. First of all is a circle with a center at the origin. As you can see in the graph, I have made a circle with a center at the origin and a radius equal to r. And its equation is x square plus y square equal to r square. This equation can be derived using the distance formula, and is written as d is equal to r, and this can be written as under the root x2 minus x1 whole square equal to y2 minus y1 whole square. And from there we have x square plus y square under root is equal to r, and therefore from here we have this x square is equal to y square equal to r square. So this is the locus of a point which has a constant distance from the origin. Now let us look at a general figure of the circle. Now let us consider that we have a circle whose center is at h comma k, and its distance when the radius of the circle is r. Then using distance formula as the same as we applied there, we have this equation h minus h square is equal to plus y minus is equal to r square. Now in general, any equation of the form this is a circle whose center is minus g comma f and radius equal to g square minus f square. C square plus f square minus c under the root. This can be made by adding terms of plus g square plus f square, and then subtracting those and forming this type of equation. From here we can get these equations. Now let us see the diameter form, which is a very important form in terms of derivation point of view. In the diameter form we are given the coordinates of the end of the diameter rather than that of the center. One method of calculating the locus can be this, that you take the midpoint of the two diameters and find the center, and then using the center and using distance formula you find the radius. But a more easy way can be like, if you assume a point xy here, and then here you have the slope of this line as m1 and m2, then there is a theorem as we studied in our lower grades that in this diameter subtends a 90 degree in a semicircle from where the point is. So using this, if we apply the new properties of straight lines, we can say that the angle between m1 and m2 is 90 degree, and therefore the product will be equal to minus 1. When we substitute the values like y minus y1 and upon x minus x1 into y2 minus y minus y2 upon x minus x2 equal to minus 1, we get this equation, that is x minus x1 into x minus x2 plus y minus y1 and y minus y2 equal to 0. So this is a very important equation from the derivation point of view because we have used the concepts of straight lines to figure out the locus of a circle. Now let us move on. It's a very important form. It's called the parametric form. Well, parametric form is a form that is so very useful that it can be used anywhere. Well, the parametric form is based on the fact that the theta changes, and we have taken a line which is called the reference level, which is denoted by RFL, the reference level. Here, the theta, which is called the parameter, or is the changing quantity. Here you should note that theta is independent of each and everything provided to us, like h, k, r, etc. Now let us look what the parametric equation is. Well, the parametric equation is given by x equal to h plus r cos theta, y is equal to k plus r. Make a correction please, this is not r cos theta, it should have been r sin theta, right? It should be r sin theta. How to derive this equation? Well, there is a very small derivation for this equation which I will tell you and will you please try it at home. First of all, for this you need to assume the coordinate axes. Assume that we have the coordinate axis here and we have 0, 0 here. Now, using the concept of transformation of axes, we can say that h can be written as x, capital X minus x. And using the formula for vectors, as I said in my last lecture, we draw up a perpendicular here. This distance here is x. So therefore, now if we another draw perpendicular here, we extend the perpendicular here, we see that this distance here is h and this distance here is r cos theta, or write it as rx. Then the coordinate x will be h plus rx, and where r is a component of this on this line which is r cos theta. Similarly, if we draw perpendiculars here and here, we can find a y coordinate. So this is the proof for the parametric form, which is a very important form in letting points on a circle or for calculation purposes. Well, there is a sign convention also with this. It says that if r is taken positive for moving in the direction of theta. Now let us see what it says. Well, it says that if we are moving in the direction of theta, then if you see my vector sign, if you closely look at this vector sign here, you will see that the vector arrowhead I have pointed in that direction, and this is in the direction of theta. Like I am going in this direction and moving in this direction. That is going in the direction of theta. Not going in the direction of theta is this and this. This is not going in the direction of theta. So now you will notice that this going in the direction of theta, we will take r as positive, and if you are moving in the opposite direction, it will be negative. So for this to be positive, this thing, the angle that needs to be taken here should be this whole angle here, this one whole angle. Or the other way around we can do it. We can take this angle here, which can be later we make it, we can take it positive, which can later make it negative. So these were the main equations involved in a circle. In my next lecture, I will tell you more advanced concepts of circles which include tangents, normals, and the more general form of the circle equation. Thank you guys for watching my video, and please subscribe for more information. Thank you.